Hello, hi. Geometric sequence have a constant ratio called a common ratio, and the general formula for geometric sequence is Tn equals to a r raised to power n minus 1. Now first we will define what is Tn. Tn is the last term. N is the last term, or we can make pen can make it like this. Where is a pen? Sorry. Is equal to the last term of the sequence. And A is equal to the first term of the sequence. R is common ratio. It's called common ratio. N is equal to number of terms. Now if you can see here, we have a geometric sequence 1, 2, 4, 8, 16, 32, 64. Every term in this geometric sequence is obtained by multiplying by a fixed number. If you multiply 1 with 2, you will get 2. If again we multiply this 2 with 2, you will get 4. Again multiplying 4 with 2, you will get 8. So it means every term is obtained by multiplying by a fixed number 2. We will get the next number of the sequence. So we have the first term here, A, which is equal to 1, as we have stated here that A is the first term of the sequence, so A is equal to 1. And the last term here, Tn, is 64, and R, the common ratio, is equal to 2 divided by 1, or we can divide 4 divided by 2, or 8 divided by 4, or 16 divided by 8. So the next term divided by the previous term, that is the way to find the common ratio. So if we divide 4 with 2 or 16 with 8, in all these cases you will get the same answer, 2. That's why we call it a common ratio. So R is a common ratio. Now n is the number of terms. So what is n in this case? Number of terms means we will count all the terms of this sequence. If we can start counting 1, 2, 3, 4, 5, 6, 7. So we have 7 terms here. So n is equal to 7. So in this case, if suppose you are asked to find the 8th term, how to find the 8th term of the sequence? How will you find that? Now we have a formula, Tn equals to ar raised to power n minus 1. In this case, we have to find the n equals to 8. We have to find T8. A, the first term, is 1 here. The common ratio is 2 raised to power 8 minus 1. So T8 will be equal to 1 into 2 raised to power, this dot stands for multiplication. So instead of dot you can put cross or dot, both we can use. So 2 raised to power 7 is, what is 2 raised to power 6? 2 raised to power 6 is 64, and 2 raised to power 7 is 128. Or you can use calculator to find 2 raised to power 7, that is 128. So the next term after 64 should be 128, because when we multiply 64 with 2, you will get 128. So this is the way to find the last term of the sequence in the 8th term of the sequence. Now in this question, Find an expression for the nth term of the geometric sequence 6, 12, 24 and so on. We can see here the number of terms. We have only given 3 terms of the sequence, and it goes on dash dash dash. So the nth term of the geometric sequence is asked. So how to find that? Nth term of geometric sequence means we are asked to find t. We are asked to find Tn. Nth term of the geometric sequence means Tn. Tn is unknown, n is number of terms. We don't know how many terms are there. So we will apply formula, but before that we will see what is A. A is 6. In geometric sequence we don't have D, we have R common ratio. R equals to 12 divided by 6. 12 divided by 6 is equal to 2, and n is equal to n because we are asked to find the nth term. So Tn equals to ar raised to power n minus 1. Tn equals to, in place of a we'll put 6, in place of r we will put 2 here, raised to power n minus 1. So it's 6 multiplied by 2 raised to power n minus 1 is the nth term of the sequence. After putting n equals to 1 here, you will get first term. So this is the answer of the question. This is the nth term of the sequence. Now in order to check it whether it's correct or not, you can check it here. How we can check it? By putting n equals to 1, we will get T1. We will put n equals to 1 in this equation. In place of n we will put 1 here. So it's 6 multiplied by 2 raised to power, in place of n put 1 here. So it's 1 minus 1. So it's 6 into 2 raised to power 0. 2 raised to power 0 is 1. So 6 multiplied by 1 is 6. So T1, the first term is 6. You can see here the first term is 6 here. Now next is we put n equals to 2. Put n equals to 2. T2 will be 6 into 2 raised to power n minus 1 is 2 minus 1. So it will be 6 multiplied by 2 raised to power 1. 6 multiplied by 2 is 12. We can see here the second term is 12. So this is a kind of check. From a check you can see, you can verify your answer, because if it gives the first term equals to 6 and second term equals to 12, it means your general formula is correct. So this is the way to find the nth term of the sequence. 2, 4, 5, 7, 6. So only first 3 terms of the geometric sequence are given to you, and the last term is also given to you. So we will start from our data. We will start to write the data here. A equals to 6. A stands for the first term, which is 6 in this case. R is, we can get R by dividing the second term to the first term. So 12 divided by 6, 12 divided by 6, you will get 2. And the last term, the nth term, the last term is 2, 4, 5, 7, 6, and we are asked to find number of terms n. We have to find n here. So we'll apply formula here. Tn equals to a r raised to power n minus 1. This is formula for geometric sequence. Last term given is 2, 4, 5, 7, 6 equals to a first term is 6, r common ratio, which is 2 in this case, raised to power n minus 1, and then further we can get this n by first dividing this 6 on this side. So it will be 2, 4, 5, 7, 6 divided by 6 equals to 2 raised to power n minus 1. So when we divide this, 6 4s are 24, and 0, 6 9 are 54, 54 3 6 6 are 36 equals to 2 raised to power n minus 1. Now we have two ways of finding the value of n, this value of n. One is to apply a logarithm, and second one is to take this 4096 in power of 2. So how we can get that? We know that it should be in power of 2. It should be 2 raised to power 8 or like that, so that we can have a same basis on both sides. So here we need the base 2. So how we can get the base 2? We will just multiply 2 that much times so that we can get 4096. We should get this answer by multiplying 2 with 8 times, 9 times, 10 times or 12 times maybe. So just check how many times we have to multiply 2 so that we can get 4096. So I ask you to find how many to find the terms of the sequence. Initially the first two terms are given, 1 over 2, 1 over 4, and then so on. The last term is given to us, and the question is to find the how many terms, means we have to find n. So let's start from the data. Find its first term, the common ratio, the n, and the last term here. Starting from the first term, a equals to, we have a equals to 1 over 2. A equals to 1 over 2. The common ratio is 1 over 4 divided by 1 over 2. So it's 1 over 4 divided by 1 over 2, which is equal to 1 over 4 multiplied by 2 over 1. When we change the sign of this division by putting multiply sign, we will take reciprocal of this. So if it is 1 over 2, this will become 2 over 1. So the resulting answer is 1 over 2. So the common ratio is 1 over 2. Last term of this sequence is, the last term is 1 over 1024. Now we'll apply a formula here. Tn equals to a r raised to power n minus 1. What is Tn? Tn is the last term of the sequence. So the last term of the sequence 1024 equals to a is 1 over 2, r, the common ratio is 1 over 2 raised to power n minus 1. Now we need some calculation here. First we will remove this 1 over 2 from here by cross multiplying 2 with 1. We will just cross multiply here. This will become 2 over 1024 by just cross multiply here on this side. 2 with 1 will become 2. So 1024 is equal to 1 over 2 n minus 1. Or we can do it in another way by dividing this 1 over 2 on this side, is 1024 divided by 1 over 2. It's like this. We can do it like this also. So when we divide this 2 will go up, multiply with 1. So this will become equal to 2 over 1024 equals to 1 over 2 whole power n minus 1. So the best way is to cross multiply it, because eventually when we do it with the other methods you will get the same answer. So after simplifying this, it will be 1 over is 2 1s are 2 and 2 5s are 2 1s are and 2 2s are 5 1 2 5 1 2. So 1 over 2 raised to power n minus 1. Now next thing is to make the same denominator on both sides, the same base on both sides. We have 1 over 2 here, so we will take this 512 in power of 2, like we will multiply 2 that much time so that we can get 512. So you can use your calculator and see how many times we can multiply 2 to get 512. Multiply We will multiply 2 9 times. 4 5 6 7 8 9. 2 raised to power 9 is equal to 512. So we multiply 2 9 times to get 512. So this will be 1 over 2 raised to power whole power 9 is equal to 1 over 2 whole power n minus 1. So we have a same base, so powers are same. 9 is equal to n minus 1 and 9 plus 1 equals to n. This implies that n equals to 10. So this is our required answer.